Hello and welcome. This is a 249 data structures video about m5lab. What I've done here, and I'm going to pull up the REPL to show you, which is shared for your use if you'd like, is the basic program. So we've got three steps. First, we're going to set it up in a non-secure fashion. So we're just going to store the password in plain text. And then we are going to hash the password. And then we are going to finally hash and salt the password. So we'll go through this step. So the first step here, I'm giving you the code, and then we're going to make some changes as we go. So I'm going to take out a few things here because in this version I haven't actually got it working. And then what I'll do is pause it and show you the working code. It was not too complicated to figure out. Again, as I mentioned here, I use hashlib. Now, because of the complexity for things that really aren't the part of the code that we care about, the hashing, in terms of the menus and all that, I'm going to suggest that you just do the Python version, even if you're usually a C++ version person, and we'll go through it that way. Again, it's a pretty short module, and we'll be moving on to the next module fairly shortly. So there's a couple of things you can do. You can register an account, you can log in, and finally you can change your password. Here are the passwords. We've stored these in a Python dictionary. The equivalent in C++ is a map, but the important thing to see here is that essentially this uses a hash table itself. Think of a hash table as like an array, but instead of storing something by the index, you're storing it by a key. So I'm storing the password under the key user. So we look up, when the user types in user, we look up user and see if the password they type matches it. Now we're using a method here called getPass, which allows us to actually run the code in such a way that you can't see the password when you type it, which is a little more realistic. And we'll be using hashlib later. Of course, we don't use it yet. So a couple of minutes to get the basic version of the program running, and then we'll add hashing and then salting. And again, I would just say, go to this REPL, copy this code directly into your own REPL or your chosen program, and that will work out fine. So here I'm going to log in, and I can see that I have the account admin and admin. So that's the getPass library there. It's allowing me to type that in without you being able to see it. And then I just print it out. So this is not very secure, but that's okay. So we did a lookup to see that the username matches. Let's look at that login code. So menu is just a menu, a combination of while loops and if statements to choose an option. What does login do? So I have a string for the username, a string for the password. I confirm that works. And then if it finds that username in the keys of the dictionary, then I check against that username to see what the password is that's been stored. And if they match, then you have a successful login, and it says welcome admin. And if I have a failed login, it does this. And I'll just put a random password. There we go. So login failed. So it does not log you in. So now I'm going to register an account, and I'll call this Charlie, and I'll give it a password. There we go. So I've created the account Charlie. So now I'm going to try to log into Charlie. Okay, and I've logged in correctly. The final piece of functionality, it's not very complicated, so I'm just going to show it to you in the code. To change password, first you need to log in, because obviously it would be a huge security hole if you could change anybody's password. You have to know the password before you can change it. So you log in, and if you log in, you are correct. So I'll show you what it looks like. So I'll change Charlie's password to, okay, and I'm going to try to log in now and see if my password has been changed. And here we go. Great. So I'll take a moment to pull up the next version of the code. Make sure your code works this way, and we'll move on in a moment. Okay, now I'm back. So this is the next version. I didn't share this REPL, so you'll need to type this code yourself. I made a few notes here to show that we're going to be using the hash, and we're going to add the salt in the third step. Now this is interesting, and this was a trial and error situation. Remember in the first program, I just created some default accounts, admin, and user password, and they existed so I could just start using the program right away without creating an account first. Well, that's not going to work in this version, and I don't want to bore you with the details, but because getPass provides a specific type of string, which is slightly different on Windows or a Unix system, and then when we hash that string, there's a slight difference in format. So even though the hashed version of the code looks the same, the hash password looks the same when it compares it, it's not the same. And so it was saying something like, let's say the password hash is 8426. It was saying comparing 8426 with 8426 does not match. So rather than figure out exactly what I'd need to do to make it work on Windows and Unix, we just have to make an account. So there's no default users here. So now I've added this method here. Again, remember you have to import hashlib in order to do this. And when you look at the documentation for hashlib, if I were to look that up, let me actually go find that. How would I do that? Well, I would do here and say Python hashlib. And you'll see that it's in docs.python.org. And there's a lot of information here. And it talks a lot about, well, if you want to have a secure password for a secure password hashing algorithm versus just a generalized hashing algorithm, there's certain considerations. Well, we're just going to use csc256. That's good enough for our purposes, and I won't get into the details. But if you do network security, you'll have opinions about whether or not this is a good enough hash. This is a test program, and of course hashlib supports a number of different libraries for hashing, different hash functions. We're going to run the program so I can kind of show you what I mean, because you may be wondering, well, what does he mean by a hash? Okay. Well, first you have the idea of a hash table, where we're storing these usernames under the passwords under the key username. So like an array, but instead of it being an index, it's a string, a key. The other use is to not use a hash table, but just use the hash function. A hash function takes a string and converts it into some value. And the important thing here is that function is one way. So this is the code you're going to want to type in. I'll just sort of leave this on the screen. It's mostly comments. So we're going to add a salt, and by default the salt is empty. And we're going to encode it as UTF-8. So this is Unicode. This is sort of the web tech. You would either use UTF-8 or you'd use ASCII. This is because this hashlib call requires a binary piece of data. It requires a binary buffer of data. And a string is a string. So you convert it by encoding it, and now this is now a binary object, a blob. So this is a blob is a binary large object. That's just a little thing people say. All right. So this is the blob. So I hash the blob, and I get back hex digest. Now, how can we use this? Well, let's look at first. Let's go down and look at the register, and look what's different. So the only change I've made here is instead of storing the password, I store the hash. So I've added this code here where I call make hash. I print out the hash, and instead of storing the password, well, looks like I made a mistake here, right? I need to store the hash. Okay, so we'll store the hash, and now hopefully this is going to work correctly. Okay, so now I'm going to register an account, and we'll see if this works. I'll do admin. So you can see the hash that was generated from the phrase admin is fairly long. So one thing about SH8256 is regardless of the string length up to a certain point, it's going to generate the same size. So now we're going to see if this works correctly. So fingers crossed. Okay, so here's the problem we see, right? So the mismatch is occurring. These strings look the same, as you can see, but they are not the same. So we're going to figure that out, and we'll come back to you in a minute. And we're back. So let me walk you through this and show you some things that I did wrong. pretty small error. It took me a while to find it, so the magic of pause met that very quick for you. So first of all, I just cleaned this up a little bit. So I'm not 100% sure that it's always going to be a Windows versus Linux problem, but even if I do get it working, you would still need an extra function to make the default users, because you can't just store the password now. You have to store the hash of the password. So we'll just make the user register an account when they start. So just to recap, this function is not changed because the bug was not in here, except of course I need to fix this back to this. I was trying a few different types of SHA. So one of the things you might look at is possible algorithms, SHA1, MD5, very broken, SHA256. Okay. If you look at the slides, so you can, if you have a given SHA1 or MD5 hash, you can just throw it into Google and it will tell you what that was. So it's very insecure at this point. 256 is okay. And now we're going to add salting to make it more secure, but this is good enough for now. Okay, so that function hasn't changed. Let's look at register first, since you're going to need to be able to register an account. So the only difference here is I call make hash. This gives me a string. I will print the string and I store it in the dictionary. Right? So we'll look at how that actually works. So when I run this program, I'm going to register an account. I'll make admin and admin. So you can see here, this is the hash that's created. It's fairly long. If you change it to SHA1, just out of curiosity, it's much shorter. It's a much shorter hash. So that's one reason why it's easier to break. Even though this is fairly short, you still get a long hash. So for anything up to, I think it's 20-some characters, you get the same size hash out of this. Now I'm going to try to log in, and so I'm going to do admin and admin again. And I see here that these two match, right? So let's look at how that code was actually implemented, because you'll need to also add login. Again, when you look at the original code, there's not much changed. The change here, there's a few things I commented out. It's just that instead of using password, what I want to do here is create a hash. I print the hash, look up the username. I pull the stored password, which is the stored hash, really. So I'm going to actually change this to make it a little easier to read. So I'm going to say stored hash. And this was the bug I had. So I was not comparing the new hash generated from the user typed in password with the stored hash. And I thought I was, because in my debug statement, I was printing it out. So this was a case where whenever you add a debug statement, you start believing your debug statement. So you need to really make sure that this code is correct. So in this case, this is correct now, because the two things I'm comparing are PW hash and stored hash. And I'm actually printing out PW hash and stored hash. Well, I was not doing that. If you have an eagle eye, you might see where the mistake was, but it's not really a big deal. So let's give this a run. Again, what will you actually be doing? You're just going to be changing this little bit of code by generating the hash and comparing the hash like so. So 4 or 5 lines of code changed. Now I'm going to make another account. So Charlie, and there we go. And I want to log in. And that works. Fantastic. So last thing I'll do, which really is kind of gravy, is the password change. Okay. Now let's see if that works. Okay. Did not work. Why is that? Because I didn't fix this code yet. So let's now, because this one isn't really a big deal, I'll just show you how this works. So what I want to do here is store the hash. All right, so essentially that's the error that I had before. I left that one in to kind of show you what happened. So now we made this change. The last thing we want to do is we need to add a salt, and I'll show you how to do that fairly quickly, and then we'll be done. And we're back for part 3. Hopefully this will finish us up. So I came up with a simple salting algorithm. And we just needed a string of random characters that we're going to save. So the important thing to remember here is, in order to make it harder to crack the hash for a given password, we don't hash the password. We hash the password plus a string of random characters called a salt. And we store that salt. So the idea here is even if someone gets access to our hashes, it's not really going to help them because the hash for password and password 1 and password 2 are totally different. So the password for password 1, 2, 3, 4, 5, 6 is going to be quite different. Let's look at how we've done this. So I've added make salt. So I just looked online for a couple of different ways to get some random characters. So this creates a list of all the possible ASCII letters and numbers. And then we just add 10 random ones to that list and return the salt. So when we run it, you'll see what the salts look like. Now we need to make a change to login. So an important distinction here is this. So you're going to want to look at this code carefully. So what's happening here is rather than just store the password hash per username, we're storing a dictionary that contains the hash and the salt. So we'll see how that looks in a minute. So this is what happens when I say, okay, look up, this gives me the dictionary contained under password's username. And this gives me the element hash in that dictionary. So, one way I could have written this would be to say something like this. I'm not going to make this change. I could just say user dictionary, so user info equals passwords username, and then stored hash equals user info hash. I'll actually my money where my mouth is, and we'll test that to see if it works. And so now I'll say salt equals user info salt. So now we have a dictionary that contains other dictionaries. So this should be good. Now watch this break. We'll see how this goes. So now I call make hash. Now this was not changed. So all I do is just add this to the end of the string. So instead, if I type in admin and the salt is 1, 2, 3, 4, 5, I'm now hashing admin 1, 2, 3, 4, 5. And then I have to store that information. But we'll look at that when we register. So I now compare these values. Okay. Now let's look at registration. Well, what happens here is I make a salt and I print out the salt. I pass the salt in. And then when I update the dictionary, I create this new dictionary itself. So this is a dictionary. And it's inside of a dictionary called passwords. So this is that user info element. I could have made an object, but I wanted to keep it simple and show off some more use of dictionaries. So I'm storing these two values in under username. Okay. And then finally, I combine these things to do change password. But to be perfectly honest, you don't have to implement change password if you don't want to. I just wanted to show it. And again, here, what I do for security reasons is I generate a new salt whenever they change the password. So whenever you type in a password, a random salt is generated, and that's what's hashed. So I'm going to run the program now to confirm it works, and then I'll scroll back through slowly so you can look the code over, and hopefully this will work. So I'm going to register an account. I'll make admin and admin. So what it hashed is admin x 8x blah, blah, blah. This is the salted hash, and that was stored. So this string was stored, the salted hash, and also the salt, since we need this information to regenerate the correct salted hash. And now I'm going to log in, admin, and I see here the stored salt, so that's the same stored salt. The hash of password plus salt is this, and that matches the stored values. Okay, so I'll make one more account here, and there's a different salt, and I'm going to log in. And I can see here that it retrieved the salt and retrieved the password. Okay, so that was a bit of a journey. Again, I'll kind of scroll through so you can see the changes. Here is the final version of make hash. This was not changed in this version, but you may want to look this over. You could use a different algorithm if you wanted to, but csc256 is pretty safe. Let's check the top again. These are the includes you need, and I labeled why you need them. for get pass, for hashing, and then salting. This is just for convenience. But we needed some way to come up with a random series of strings, of string characters. So make hash here. As we see, I take password plus salt. I encode that to a binary piece of data. I then hash that into a hex digest, which is a string. So I have to convert a string into a piece of binary data and then back into a string. But that's just how this works, because the hashing algorithm works on binary data. All right. Now for make salt, I generate a string of random ASCII characters. I could change its length if I wanted to make it a little more secure, but it's not a really big deal. And then the final changes again here are I updated this portion of the code. So the first version, we just checked for the password that was stored. Then we checked for the stored hash of the password against the hash of what they type in. And finally now, we retrieve the salt for the username, add the salt to what they type in, hash that, and compare that with the stored hash. So multiple steps, but very secure and should work out well. All right, thanks a lot. I know this has been a long one, so thanks for bearing with me, and I'll see you in the next module.